Hello and welcome to drillingcontractor.org. This is Kelly Ainsworth Robinson at the 2018 SPE and IEDC Managed Pressure Drilling and Underbalance Operations Conference in New Orleans. I'm with Brian Piccolo, Technical Sales Director for AF Global, to learn more about a new condition monitoring system they're developing. Thank you for joining us today, Brian.
Thank you. It's good to be here.
How do operators typically know when their wellbore seals need to be changed out?
Typically, with a passive RCD, the operator knows to change out the seal elements when there's a loss in wellbore sealing integrity. This is reactive in a way, and basically there's a loss in wellbore pressure or a leak past the seal elements or bearing assembly into the trip tank. Now, with active systems, like the active control device, or as we say for short, ACD, this is altogether different. What we do is monitor control systems pressure over time and look for a change in behavior that indicates to us that our element is near end of life. Keep in mind, when I say near end of life, there's still hours of rotational life there. We're able to indicate that we have a change-out state status and change out that element before there's any loss in wellbore sealing integrity at all.
How does the condition monitoring program AF Global is developing and testing use annular packer pressure to determine whether a seal is nearing the end of its useful life?
Let's take a step back and talk about what an ACD is and how it works first. So, an active control device consists of two industry standard, very much conventional MPD annulars. We have an upper and we have a lower. And in fact, if you've been on a deep water MPD job, it's quite likely that you've already seen this equipment at work. In addition to that, what we do is lay across each MPD annular a consumable sealing element, which you can see here in green. The way the ACD is operated is that we apply closing pressure to the MPD annulars to close in on the sealing elements, enabling them to engage drill pipe and form a wellbore seal while drilling. Now keep in mind, while this process is occurring, absolutely nothing in the ACD is rotating. There are no bearing assembly, there are no rotating comparts in this system at all. Now the way that we're able to achieve this is through two features that the ACD has to minimize abrasion. The first feature is that we inject clean drilling mud through the 2-inch equalization and bleed-off hose into this chamber that you see right here. We then pressurize this chamber and allow drilling mud to lubricate up through the upper element drill pipe interface and lubricate down through the lower element and drill pipe interface. This reduces abrasion. The other thing that it does is keeps a positive differential in this chamber over wellbore pressure, and that allows us to effectively have a third barrier. Now, the second thing that happens is basically within our seal element design. Our seal element consists of polyurethane co-molded with a PTFE or Teflon matrix. The Teflon is highly abrasion resistant, and this enables us to extend the operating life of our elements by a substantial amount. Now, the other thing that the Teflon does in having such a long wear life is that it allows us to run the system with very little adjustments in packer pressure. For conversational numbers, let's say that when operating this system and sealing on the Teflon, I might increase packer pressure by 10 psi about every 6 to 8 hours. However, when the Teflon matrix wears away, I'm now sealing on polyurethane. I have a very robust wellbore seal in that condition. However, the polyurethane is obviously less abrasion resistant than the Teflon, and that means that I need to increase my packer pressure more frequently. Once again, for conversation, this might be a 10 psi increase every 10 or 15 minutes as opposed to every 6 to 8 hours. This stark change in packer pressure set point behavior is a very sharp indicator to us that the Teflon matrix has worn away, and we consider this to be the MPD seal element change out state. Now, once again, once we're there, we still have hours of rotational life on the polyurethane, so we're not worried or have not seen any loss in wellbore sealing integrity. Instead, we can plan to change out the element at a convenient and safe time.
Can you tell us about the drill mode testing that's been performed at your Houston test rig and the results that you've seen?
So the drilling mode testing that we're doing in Houston on our test rig is intended to replicate full-scale actual drilling conditions. We do this in two key ways, or the two biggest ways are: first, we simultaneously rotate and strip drill pipe through our system. This is what we do in drilling. Secondly, we use actual drill pipe, 8.5-inch tool joint with tong marks, ID grooves, and hard banding. These are the kind of things that gouge and scrape away at elements. And so when we do all of this, we feel that we give ourselves and the end client a realistic assessment of how this equipment performs in the field. This is very different. They use polished mandrels for this testing, and also rotation and stripping are done as two independent tests. There may be some value for this in terms of baselining, but we don't feel that it gives you a realistic assessment of the equipment's performance. Now, in terms of results, we do perform the 16 RCD testing, just like all of the other players in the industry do. We have a 1500 PSI dynamic rating and a 2000 PSI stripping rating. However, when we talk about drilling mode testing, we talk about the results in a different way. So just recently, we were able to operate one set of seal elements for 118 hours at 160 RPM, 250 PSI of back pressure, and drill at 90 feet per hour. To put this into perspective, if you haven't looked at the numbers in this way before, that's equivalent to us drilling nearly 11,000 feet of hole with one set of sealing elements. And to add on to that, the way we knew to terminate the test at 118 hours was through our condition monitoring program. Our packer pressures on the ACD indicated to us that it was time to change out the elements, and we were able to do this without any loss in wellbore sealing integrity at all.
And what are the next steps in the development of the condition monitoring system?
The next steps involve a lot more fingerprinting. What we're really going towards is a condition monitoring system that not only tells us when we're near end of life, but when we're perhaps halfway through our life or a third of the way through the operating life of those elements. And so the way to do this, like I said, is a good deal more fingerprinting. We'll look at packer pressure behavior over time at different wellbore sealing pressures, and we'll also visually inspect the sealing elements periodically along the way to get a clear understanding of their status. And in the end, like I said, not only will we be able to determine when we're near end of life, but make assessments on how much life is remaining along the way.
Brian, thank you so much for joining us today and telling us about the new condition monitoring system.
Thank you for your time. Appreciate it.
And thank you for joining us on drillingcontractor.org.